This video presentation will cover the operation and testing of the rear window defogger and heated windshield systems. The rear window defogger system has two main components, a rear window grid and a control assembly. The control assembly mounts to the dashboard and serves as the on-off switch and the timer for the system. The timer limits system operation to about 10 minutes. System testing requires the use of a voltmeter. No special tools are needed. The grid wires can be tested by attaching the voltmeter leads to the battery and ground strips on the grid with the system on. The voltmeter should read between 10 and 13 volts. If the voltmeter reads 0 volts, test the voltage applied to the battery terminal of the grid using a good ground for the meter. If the voltmeter now reads between 0 and 10 volts, there is either an open in the ground harness or a loose ground wire connection. Testing for an open grid wire involves measuring voltage at the midpoint of each grid wire. Be careful not to damage the grid with the voltmeter lead while doing this test. The voltmeter should read about 6 volts. A higher reading indicates an open in the grid wire between the midpoint and ground. A reading of 0 volts indicates an open between the midpoint and the B+ side. Open grid wires can be repaired using Ford Rear Window Repair D8AZ-19562-AA. Consult the shop manual for specific details on repairing the grid. The heated windshield system works a bit differently. This system operates on 30 to 70 volts instead of 12. The components for this system include the windshield, high output alternator, alternator output control relay, sense resistor, control module, and on-off switch. The windshield grid is fused between two layers of the windshield glass and has a resistance value of about 2.4 ohms. Unlike the rear window, the windshield grid cannot be repaired. If there is an open in the grid, the windshield must be replaced. The alternator output control relay is located by the battery and the radiator support bracket on Continental, Crown Victoria, and Grand Marquis models, or on the passenger side fender apron on Taurus, Sable, and Town Car models. This relay serves as a switch to distribute alternator output voltage either to the vehicle electrical system or the heated windshield circuit. The control module is located behind the glove compartment on Crown Victoria, Grand Marquis, and Town Car models, or on the right side steering column support bracket on Taurus, Sable, and Continental models. On past models, different control modules were used and cannot be interchanged. When replacing the control module, be sure to use the correct one for that system. The 1991 models use a common control module. The same control module is used on all models. The functions of the control module include operating the alternator output control relay, limit system operation to 4-minute cycles, sense passenger compartment temperature, control fast idle speed, and prevent system operation with a damaged windshield. The sense resistor is located near the alternator output control relay. The control module uses this resistor to detect a damaged windshield. The control module monitors the voltage across the sense resistor and turns the system off when it detects a voltage drop. The on-off switch is located on the dashboard to the right of the steering column. It is a push-type switch and contains a lamp to show when the system is on. Depressing the switch turns the system on, and depressing the switch a second time turns the system off. A combination heated windshield and backlight switch is used on 1987 through 89 Crown Victoria and Grand Marquis models, and 1990 Taurus and Sable models. The lamp on this switch indicates rear window defogger operation only. Before the heated windshield system will operate, the following conditions must be met. The engine must be running. Battery voltage must be at least 11 volts. The vehicle interior temperature must be below 10 degrees Celsius, 50 degrees Fahrenheit, and the windshield must not be damaged. Turning the heated windshield on signals the control module to turn the voltage regulator off. This stops the alternator from producing voltage. Then the control module energizes the alternator output relay to switch the alternator output line from the vehicle electrical system to the windshield circuit. Then it turns the voltage regulator back on, with the alternator output line removed from the vehicle electrical system. Battery voltage drops to 12 volts. The voltage regulator senses low battery voltage and full fields the alternator. The heated windshield now has full alternator output applied to it. This should be from 30 to 70 volts. The voltage regulator protects the circuit by limiting alternator output to 70 volts. The system will turn off after about 4 minutes, or when the switch is depressed again. Turning the heated windshield off signals the control module to turn the voltage regulator off, de-energize the alternator output relay, and turn the voltage regulator back on. Alternator output now returns to the normal vehicle electrical system. The system will go through this cycle again if the switch is depressed a second time. Turning the system on also causes the control module to signal the EEC4 module. The first time this happens, the EEC4 system increases the engine idle speed to 1400 RPM. This helps the alternator supply enough voltage for heated windshield operation at idle. After the first cycle, the idle speed will not increase if the system is activated a second time. Putting the vehicle in gear causes the EEC4 module to cancel the heated windshield fast idle signal. The air conditioning system ties into the control module to override the heated windshield fast idle signal. Turning on the AC while the heated windshield is on cancels the fast idle speed function of the heated windshield system. This does not mean that the heated windshield and AC cannot operate at the same time. Before testing the heated windshield system, certain precautions must be taken. This system uses from 30 to 70 volts during operation. Exercise extreme caution to avoid possible personal injury. Before testing the components of this system, a few simple checks can save a lot of time. Check the electrical connections at the battery, alternator, regulator, and alternator output relay. Poor connections affect system operation. Check the condition and tension of the alternator belt. A worn or loose alternator belt can prevent the alternator from supplying enough voltage for the heated windshield. The tools needed for testing this system are a digital volt ohm meter, jumper wire, EEC4 monitor, monitor template, and adapter cable. First, test the normal charging system function by checking voltage at the battery with the engine running. A defective battery or charging system will prevent heated windshield operation. Remember, all vehicles equipped with a heated windshield must use at least an 84 amp-hour battery. If battery voltage drops below 11 volts, the system will shut off. The next test involves checking alternator output. The heated windshield system has a test lead for use when the temperature is above 10 degrees Celsius, 50 degrees Fahrenheit. The test lead is located on the passenger side of the engine compartment. Only use this lead for testing. Using a jumper wire, ground the test lead. This overrides the temperature control, crack sense detection, and low battery cutoff functions of the module. Start the engine and turn the heated windshield on. Verify that the lamp on the switch lights and stays on. Run the engine between 1,000 and 1,500 RPM and note the voltage reading at the bat terminal of the alternator. The reading should be above 30 volts. If the voltmeter reads 13 to 15 volts, check the continuity of the test lead to the module. If the test lead has continuity from the engine compartment to pin 4 of the control module, replace the control module. If the voltmeter reads 0 to 12 volts, testing of the charging system is necessary. Refer to the shop manual for the proper procedures. With the engine off, turn the ignition switch to the run position and turn on the heated windshield. Voltage at the mod terminal of the alternator output control relay should be about 1 volt. If the voltage reading is correct, ground the test lead and run the engine with the system on. Voltage at the WS terminal should read over 30 volts. If not, replace the alternator output control relay. With the mod terminal wire removed, the mod and bat terminals should each read at least 12 volts. If the bat terminal reads 0 volts, repair the circuit to the battery. If the bat terminal reads at least 12 volts and the mod terminal reads 0 volts, replace the alternator output control relay. Voltage applied to the windshield can be tested by grounding the test terminal and measuring the voltage at the windshield connector. Voltage should read over 30 volts. If not, locate and repair the open between the alternator output control relay and the windshield. Testing the windshield requires measuring the resistance of the grid. The grid resistance should be 1 to 4 ohms. Testing the sense resistor requires disconnecting the electrical connector and measuring the resistance of the sense resistor. The meter should read 0.5 ohms or less. A higher reading shows the sense resistor needs replacing. Control module testing can be done using the EEC4 monitor and the 007-00060 adapter cable and template. With the ignition switch in the off position, access the control module, disconnect the electrical connector, and install the adapter cable leads. Attach the monitor tester to the adapter cable and secure the black lead to a good ground. Locate the readout so it can be viewed easily and install the monitor template around the dial. With the pin type switch in the blue position, the values for pins 1, 2, 3, 4, 6, and 9 can be read. The red position allows pins 5, 7, 8, 10, 11, 12, 13, and 14 to be read. Move the aim switch to the key on engine on position. This places the monitor in the test mode and bypasses the temperature control feature of the control module. Start the engine. Turn the heated windshield switch on and turn the monitor power switch on. The LEDs on the monitor show various areas of the system operation. A lit test LED shows the temperature control bypass works. A lit ground LED shows a defective or missing ground potential at the control module. A lit AC LED shows the air conditioning is off. A lit CR LED shows the heated windshield is on. The EEC LED shows when the idle speed increase signal is present. It will flash during operation. The values for the various pins can be seen through the readout by turning the dial to the appropriate position. Pin 1 is the system switch position. The correct values for this pin will vary depending on the vehicle. Refer to the shop manual or diagnostic manual for the specific values. Pin 2 is for the control module ground circuit. It should read 0 volts with the heated windshield on or off. A voltage reading here would indicate a poor module ground. Pin 3 is for the AC switch input. It should read 0 volts with the AC off and 13.7 volts with the AC on. Pin 4 is for the test signal. It should read 0 volts with the heated windshield on and 5 volts with it off. A reading of 5 volts with the heated windshield on indicates a poor test connector ground. Pin 5 shows the duty cycle of the idle speed control line. It should read around 50% with the heated windshield on and 98% with it off. Pin 6 shows the ignition voltage value. It should read around 11.6 volts with the heated windshield on and 14 volts with it off. Pin 7 shows the regulator I-line value. It should read around 1.2 volts with the heated windshield on and 8.6 volts with it off. Pin 8 shows the indicator light value. It should read around 11.6 volts with the heated windshield on and 13.7 volts with the system off. Pin 9 is the switch-off signal and only applies to the Taurus and Sable models. It should read 10 volts with the heated windshield on and change to 0 and then 10 volts when it turns off. Pin 10 is for the sense resistor. It should read around 1.5 volts with the heated windshield on and 0 volts with it off. A lower value indicates a damaged windshield. Pin 11 is the voltage applied to the windshield grid. The voltage value displayed must be multiplied by 10. It should read 3 to 5 with the heated windshield on and 0 with it off. Pin 12 is for the alternator output control relay coil. It should read less than 1 volt with the heated windshield on and 13.7 volts with it off. Pin 13 is for the regulator S terminal. This pin is used for all models except the town car. It should read near 0.5 volts with the heated windshield on and around 5.3 volts with it off. Pin 14 displays alternator stator voltage. The voltage value must be multiplied by 10. It should read from 0 to 2.4 with the heated windshield on and around 0.75 with it off. The tests that were done through the EEC4 monitor can also be done using a digital volt ohm meter. By backprobing the control module connector, the pin values can be read. Consult the shop manual for specific information about testing this system with a digital volt ohm meter. This concludes this video presentation on heated glass systems. If you still have questions about the procedures for diagnosing these systems, consult the shop manual and heated windshield supplement for further information.